Hello, welcome to this edition of Momentum. I'm your host, Robert Green. Very happy today to be joined by Dr. Shahram Rahimi. Dr. Rahimi is professor and director, or department head of our Computer Science and Engineering Department. He also holds the Gloria and Douglas Marchant Chair. Dr. Rahimi, welcome.
Thank you so much. I'm happy to be here.
Yeah, happy to have you. So I want to start asking you a little bit about computer science. It's a very broad topic, and of course your department is computer science and engineering, so it has many different degrees in it.
That's right.
But a common question I get is when students think computer science, they think programming.
Yeah.
But you and I both know it is much more than programming. So can you tell us a little bit more about that discipline?
So first thing to talk about that people think about when they talk about computer science, naturally is programming. However, it's much more than that, as you mentioned. Anything that relates to the software, whatever task that is, from designing it, building it, developing it, testing it, using it, applying it, is part of computer science. So we do fundamental theory, we do software engineering, which is a cycle that included software management and production and so forth. We do cybersecurity, that includes privacy and all those good elements there. We do AI, machine learning, we do robotics. So all of add to that cloud computing, distributed systems, high performance computing. Now, you might have some programming in some of the elements of all of this, but you might actually end up not doing much of programming at all and be doing other elements of the cycle of the software generation and utilization.
Okay, so you did mention one of the majors I wanted to talk to you about, software engineering. We didn't just stick engineering on the end of computer science to make it sound cool. You do offer a degree in software engineering. Tell us a little bit about that.
Sure. So software engineering, like other computing related majors, computer science and cybersecurity and so forth, they have a lot of similar cores naturally, because you got to get to a point that you can focus and be more specialized in some particular tracks. However, the part that software engineering focuses on a lot is this part of the management and the cycle of generation and engineering of the software. So from design and planning and project management to testing and evaluation and applying, those cycles, that a lot of those comes from the side of the management also, is in software engineering. So if people are interested in that side, definitely software engineering could be the right core for them, versus computer science has focus on foundations and fundamental more than what software engineering does.
Okay, good explanation. So what about you? How and why did you get interested in computer science?
Yeah, I mean, I think when I talk to people and students coming into the department and visiting us, I usually get really excited when I'm talking to them, because truly I have been always excited about computer science. The thing about it is amazing that you can do the next big thing with this little computer and a quiet corner you can find, and build the next billion-dollar corporation. All these corporations you see out there, like Google, like Microsoft, and so forth, if you go back, Facebook, they started with one computer, one person, and an idea, and they develop it. So it's not like any other engineering necessary majors, like if you want to do material science or mechanical engineering or aerospace, you got to have other tools and other elements there. Versus in software in computer science, you can do big things with a little kind of package that you have in hand.
Yeah, interesting. So one thing you do, and a problem we're having nationwide, I guess actually worldwide, is cybersecurity.
Right.
So can you tell us a little bit about cybersecurity, what your department is offering there?
So our department is actually one of the top cybersecurity departments in the nation. We offer a Bachelor of Science in Cybersecurity. We offer a master's degree in cybersecurity and operation with track of defense and offense. We also offer now a Bachelor of Applied Sciences, B.A.S degree in computer cybersecurity, which, if we get there, I would explain what's the difference between Bachelor of Applied Science and Bachelor of Science in cybersecurity. But we have all this multiple, and even also in our PhD program, we have this track, that concentration that focuses on cybersecurity, and we have multiple PhD students that are doing that. As you know, we have multiple designations for cybersecurity. So if I expand your question to talk about that, there are 3 possible Center of Excellence designations you can get from NSA, National Security Agency. They are NSA Center of Excellence in Cyber Defense, Center of Excellence in Cyber Operation, which is offense, and Center of Excellence in Cyber Research. Very rare that a university has all 3 of them, but we got all of them. So there are less than 10 universities in the nation, and all really top schools that have all 3 of them at the same time. Mississippi State University is one of those 10.
Yeah, well, I know you're proud of that.
Very proud.
Yeah, and worked hard to get it as well.
Absolutely. It's not easy. Otherwise, others would have it too. Yeah.
Right, yeah. Well, you brought up the topic, and it is something I want to talk about. What is the difference between a B.S, a Bachelor of Science degree, and a B.A.S, a Bachelor of Applied Science degree?
Right. So the focus of Bachelor of Science in cybersecurity is more similar to the core of computer science, means they design and implement and build those applications and technologies for cybersecurity. Bachelor of Applied Science in cybersecurity is more focused on hands-on, more focused on using those technologies and applying those software and technologies and applications that Bachelor of Science in cybersecurity would build. Now, they both have common programs and common cores that they have, but then after the first and second year, they start doing hands-on versus more theory and more build-on in these 2 tracks. So if people are more interested in applying Bachelor of Science and applying cybersecurity, and maybe less in those theoretical and core, like calculus 1, 2, 3 you would have to take and all that, then they would go the track of Bachelor of Applied Sciences. One other thing I want to mention is that we built that program especially for students that would get a 2-year degree from colleges.
Okay.
And they can transfer to our B.A.S program and then continue, and in a couple of years get their B.A.S in cybersecurity. That's another difference.
Yeah, so come from a community or a junior college here and then get a degree in 2 years. Well, interesting.
Yeah.
Okay, well, you can't open the news today without hearing something about artificial intelligence.
Yes, sir.
It's either going to save the world or be the doom of everything.
True.
Can you tell us something about what's going on with artificial intelligence?
Yeah, I mean, it's coming, and it's here, and it's here to stay. One interesting thing that's usually when we start talking about artificial intelligence, I bring up is that artificial intelligence, interestingly, is not a buzzword. The term artificial intelligence came before the term of computer science. And it's in something that started to come around in 40s, and the term was introduced in 50s. And at that time, we had no computer science department anywhere in the nation. So AI has been there. Now, it has ups and downs.
Yeah.
Technology changed, especially the ideas and expectations early on was way over the capacity of the hardware being able to deliver that. Now that we have that capacity, a lot of those older algorithms and technology that we just talked about and thought about, now we can implement it. So like any other technology, I always think that artificial intelligence also should be utilized appropriately. If we use it appropriately, it would work well. If we don't, it's going to cause trouble too. But I'm very hopeful and positive on what changes AI going to bring to the society.
So what are some areas you think that would be appropriate for artificial intelligence, where it really would help us, and areas where we may need to be a little more concerned and look at some policies?
Yes. So that's a very good question. And there are a lot of research now going on looking at those type of policies. Of course, areas that AI can be applied to is anything we do daily, from healthcare to transportation to education, to to security. All of those elements that are core elements that we're trying to get better in them and improve in them are also connected to AI, and AI can do a great job on it. Now, we have scary areas too, going after people and, making sound and image and voice of someone and calling others to go after money and doing those kind of cheatings or military purposes. There are issues or there are examples of fully autonomous robots that use very advanced AI that now can go to the field and fight. So I think the use of AI and application of AI in societies should be carefully looked at. They are also tools like machine learning. They learn from what you provide them. So if you give them examples that is biased, they're going to be biased. So if they think this type is more concerning than that type, that's what they're going to think, and then they're going to increase that bias in the society. So we have to be careful how we apply it very much.
Yeah. So you mentioned robotics
Yes.
and autonomous robots. What's some of the work you're doing in your department?
Yes,
along those
our
lines?
department just purchased $300,000 of advanced robots, including 3 dogs. One of them is a very large dog that we purchased. We use these dogs to implement and apply and evaluate collaboration between robots and multi-agent systems, like the group hunt and those kind of things. We have multiple arms in our labs. We have 2 major labs for robotics right now. We have Raptor Lab and Stars Lab. Stars Labs build robots that relates to social sciences and human-computer interaction. And then Raptor Lab is more into the core robots. So we have a lot of courses related to that too. So we have human-computer interaction course. We have robotics, AI robotics, and so forth. So very active in robotics area.
Okay. We've got about a minute left, so I want to ask you, you've got a very active department, very involved in research, offering multiple degrees. What advice would you have for a student, say 6th grade or high school, thinking about a career in computer science? How can they decide which discipline, which sub-discipline they want to follow?
Yeah. So first of all, I would say everybody has to get engaged, and they have to play with this, no matter if they are going to do computer science or do something else. These days, we all utilize technology in computing in a variety of the areas, very, very interdisciplinary. But I would say that they look to see, are they more interested in hardware building or software building? And if they're interested in the software side, then naturally computer science and software engineering and cybersecurity would be better fit. And if they are interested in the hardware side, then computer engineering, electrical engineering would be the better fit for them. So they have to get a sense, are they more hands-on and they want to build the stuff, or they want to use computers? But they got to get engaged, have a feeling about it, and see if they are really interested to go after it.
Yeah. Well, and I hope we'll get more in it, because it sounds like it's a growing field with great career futures. Well, Dr. Rahimi, I want to thank you for taking the time today and joining us here today. And I want to thank you all for joining us. I look forward to seeing you next time on Momentum.